count every individual. If you observe the definition, he is giving a very precise statement that individual unit. This individual unit can be a combination of variables. It can be identifiers. It can be operators. It can be special symbols, or it can be any symbolical representation. We frame that word as a token. So now in this statement, how many number of tokens do we have? 1, 2, 3, 4, 5. So your answer should be 5. What are these 5 tokens? We have 3 variables of type A, B, and C. And we have 2 operators. One is multiplication operator and the other one is subtraction operator. Okay, so you will be writing this small example. If they ask even write the definition of token, you will write the definition and you have to by default give an example to count the number of tokens. Okay, now these tokens are broadly classified as, the first one we call it as keywords, the second one we call it as identifiers, we have operators, we have variables, constants, and the last one is special symbols. So tokens are broadly classified into 6 types: keywords, identifiers, operators, variables, constants, and special symbols. So remember one thing, any programming language, if any user want to design his programming set, that is nothing but his set of instructions, definitely he is going to use these type of tokens. So these tokens can be a keyword, it can be an identifier, it can be an operator, variable, constant, or any special symbol. So we are going to explain them in detail. Okay. So first let's talk about keywords. So as textbook definition says, keywords are reserved words. Exactly. They say that keywords cannot be used as variable names. Or identifiers. Okay, you will write examples for these keywords, like you have your int, char, so on. Okay, so remember one thing, they say that keywords are reserved words. Keywords cannot be used as variables and identifiers, but this statement you have to precise it in a very good fashion. Keywords can be used as variables and identifiers if you have no ambiguity problem. Okay, so with keywords cannot be used as variables or identifiers in case of ambiguity. So we'll see what is this term ambiguity. So I'll show you an example. For example, you all know that printf is a reserved word. So you people have a basic idea that printf cannot be used as a variable name, but it's wrong. We can use printf as a variable name, as I told you to mention if there is no ambiguity problem. So understand here how that ambiguity, what does I mean? So if you observe here, I have declared a statement called printf of an integer. So we all know that printf is a method, or it is a reserved word, or it is a predefined function method. So a few of them say that you can't use a printf as your variable name. No, you can use it as a variable name if there is no problem of ambiguity. What is that is, for example, now if I execute this piece of code, I should get an error, right? Because you are using a reserved word as a normal variable of type integer, but your compiler will not do any error. It will accept an input from me. You can observe that. So if you see your programming success and it is taking input from me for the keyword printf, I'm just reading the input. Now, when this ambiguity is, suppose if I have initialized printf with some value, and if I try to use printf here again. Okay, now this is an ambiguity problem because in the fourth line, you are explaining your compiler that I want to use a printf variable of type integer where I have initialized a value as 90. That is, you are making printf act as an identifier or a variable name. But when you see your line number 5, you are using at a time printf as a function call here, as a wizard one. Like with the help of printf, you are printing a value for printf. So this is an ambiguity. In this case, we cannot use your keywords as your variables or identifiers. Okay, there is an ambiguity problem. So you're making your processor to get confused. Either you want to use your printf as a normal variable or you want to use your printf as a predefined function. Such cases will throw you an error. So this is an error. That is the error what it is given. Okay, now I'll do one more. You can change here. Now if I use here scanf, let's initialize some another value, and if I try to print scanf here, this should work because clearly you mentioned in line number 4 you want to use scanf as a user defined variable, and in line number 5 you're printing the value of scanf in the statement printf. So this works. So you get your output. So hope everyone are able to see this output, right? Can you all see my screen? So now we can show, yes, okay, fine, thank you. Now, for example, I can write here main. Okay, this also works. Why? Because I already mentioned you main is a user-defined function. It is not a predefined function. So any user-defined variables at a time can be used as method names, and they can also be used as a local variables. So I can use main as my method form, okay, for program execution. In the similar way, I can use my main to print my value, whatever is being initialized. So it will print my value as 9. So hope you understood what is the line, whatever I have mentioned. Like keywords are reserved words and they cannot be used as variable names if you don't have the processing of an ambiguity. That was very important line which you have to mention. So ambiguity means you are not making your compiler to get confused whether you want to use your reserved words as a name or you want to use them as a user-defined functions. Understood everyone? Keywords. So the first point, these are reserved words. Okay. Keywords cannot be used, or you write them differently, can be used as identifiers or variables. If we don't have a property of, if we don't have ambiguity. And for this, you can give basic examples like your int, char, if, and so on. So everyone understood with this keywords concept? So that I move to the next token keyword identifiers. So we have identifiers and variables almost fall in the same category. So we have different rules for identifiers and variables. First of all, any identifier, the first letter can be either underscore, this, okay, we'll write the first letter of an identifier should be an alphabet. No white spaces or special symbols cannot be used between identifiers. Okay, and only one special operator or one special symbol that is allowed as an identifier is underscore. One special symbol allowed in defining your variable names is underscore. So these are the rules of identifier and variables. So always whenever the user defines his identifier or a variable name, always the first letter should be an alphabet. No white spaces or special symbols are not allowed in order to define your identifiers or variable names. One and only one special symbol that is allowed to define your identifiers is nothing but your underscore. Like, for example, you can write int ABC, like you will throw some examples for him. So if you see, I gave 5 examples here. So if you see the rules of identifiers, we know that if you see line number 1, ABC is my identifier. That is nothing but a variable name. So it is allowed. This is valid case. You will write it as valid statement because the first letter is an alphabet which is allowed. Now when you observe line number 2, it is also valid because you can use your underscore as your special symbol. Right? So this will be also a valid statement. Now, when you observe line number 3, it is an invalid because as the rules of identifier says, either your first letter should start with an alphabet or it can be underscore. But here you have a numerical constant which is not allowed, so you will write it as invalid. Now, if you see line number 4, A is an alphabet. Dollar is a special symbol. So this is an invalid statement. You can't use special symbols rather than underscore. So this is an invalid syntax for your identifier. And if you see the line number 5, it is purely valid because you have the first letter as alphabet and underscore is allowed. So this is a valid syntax. Okay, understood with identifiers? Anyone has any doubt with identifiers? So you will write these points. You will write these points. What is an identifier and a variable? These 3 lines. That is, first letter should be an alphabet. No white spaces or special symbols are allowed in between. Okay, and only one special symbol that is allowed to be used as an identifier is nothing but your underscore. Okay, so this is about your identifiers and variables. So next we have constants. So the next one is, let's talk about constants. So your constants are categorized as numerical constants and you also have something called as string constants. Okay, what are numerical constants? Numerical constants are further classified into different types like decimal numbers, floating point numbers. You can have decimal constants, floating point constants, you can have octal constants, you can have hexadecimal constants. Okay, all these comes under the category of numerical. That is, if you are representing any value in the form of any numerical mod, either that numerical mod can be decimal, it can be floating point, it can be octal, or it can be hexanode, then it comes under the category of numerical constants. Now, when you're talking about string constants, they are purely categorized into 2 things. String constants are categorized as 2 types. Your first one is single character constant. And the other one is string constants. So string constants are categorized as 2 types. The first one is single character constant and the other one is string constant. What are single character constants? Always a single character constant. Let me erase. So we are talking about string constants, which are broadly taken as 2 groups. First one is single character constant. and the other one is string constants. So when you are talking about single character constants, always your single character constants you will represent with a keyword, or you will define with the keyword char some variable name. Okay, char followed by variable name. Always if you see the ch is going to accept only one, that is you can only initialize one character constant to this. So this, and always remember single character constants are enclosed in between single quotes, and always ch can accept only one input. That is, it can only read one character. The name itself says single character mode, so it can read only one character, not more than that. Now, when you are talking about string constant, string is nothing but group of characters. And to read your single character constant, we use %c. So string constants are nothing but group of characters. It's nothing but you call it as a string. Here you can read n number of characters into a string depending on the size, whatever you are going to define. Like this is acting as your character array. And in order to read a string, we use generally, like for example, I write char ch of 3 is equals to, you can use double quotes, and I can write here AB. And always in order to read your string, we use %s. In order to read the character, we use %c. In order to read group of characters, that is nothing but a string, we use %s as your format specifier. Okay. So for example, you'll write basic examples. Remember one thing, in your exam, it's very good if you write a simple examples for every concept, even they asked or not. It looks more precise for them to understand, the concept well, because it's a programming subject. Learn one basic program which can be used everywhere. So I'll write char ch. Okay, scanf. So it will read one character. So whatever the character is read, it is printed. It can only read only one input, as I mentioned, because you are using ch as a single character constant. Now here I can make a change. If I give some 5, now your ch is not the character constant, it is acting as a string constant. Now instead of %c, I will be using %s. For strings, no need of using address of symbol. And to print, you can use %s. Instead of character, you modify it as string. So you get the same output. Okay. So that is the difference between the single character constant and string constants. Okay. So now, so the first one we have seen keywords. Then we have talked about what are identifiers. Then we have talked about variable, and identifiers and variables both fall in the same category. Then we have seen about constants, numerical constants and string constants. Next we'll talk about special symbols, then operators. So under special symbols, you can write, we have different special symbols which are being used, like dollar, modulus, star, cap, exclamatory. All these falls under special symbols. That is only about special symbols, nothing much to learn about. Now, the next most important thing is we are talking about operators of C. So, we have different types of operators in C programming languages. Okay, so we have the first one, the basic one, as arithmetic operators. We have then logical operators. We have relational operators. We have bitwise operators. We have assignment operator. We have ternary operator. You can also call a ternary operator as conditional operator. Okay. We have increment decrement operator. And the last one is we have special operators. Special symbols are different, special operators are different. So 1, 2, 3, 4, 5, 6, 7, 8. So we have operators as 8 categories. They are the naming conventions. So first, we will talk about the basic one. The first one is arithmetic operators. Okay. So arithmetic operators are broadly categorized as 5 types. First one is addition. Then we have subtraction. Then we have multiplication. Then we have division. Now we also have another one that is nothing but modular division. So when you are explaining about arithmetic operators, you will be writing arithmetic operators are broadly classified as addition, which is represented by symbol plus, subtraction, which is represented by symbol minus, multiplication, which is represented by symbol star, division as division, and modular division is represented by percentile symbol. So in this arithmetic operators, only one concept you have to include, that is nothing but the difference between division and modular division. So you will write a point. The difference between division and modular division is always a division operator returns the quotient of given expression, and always a modular division will returns the remainder of a given expression. So here you can take small example, like you define int a is equals to 10 and b is equals to 5, and you write a simple printf statement percentile d a divided b, and you write one more statement printf percentile d a modulus of b. When I experiment this, as I mentioned, a divided by d should return me the quotient. So you get here 2, and a modulus b modulus will return me the remainder. Here you get the value as 0. So you write this example and you are going to precise the output of this program, that is expected output of this program. So you will get a divided b will return you the quotient. So you get the quotient as 2, and a mod b will return the remainder. You get the remainder as 0. Okay, this is about your arithmetic operators which you are going to explain. Okay, clear with this, everyone? Yes. So the next one we are going to talk about relational operators. Okay, so you all know whenever you see relational operator, okay, whenever we observe a relational operator, relational operators are nothing but you will be having, you are going to define the relation between two operands. So here I tell you, for example, I have C is equals to A plus B as my statement or my expression given. A, B, C are called as operands. Always your variable names which we are going to use, we call them as operands, and your equal to and these plus, we are calling them as operators. Okay, so now you have different types of relation operators like greater than, less than, greater than equal to, less than equals to, not equals to, and you have equals to operator. Okay, so any relational operator is going to judge between the two statements what is the relation that is happening in between different operand values. Okay, whether the relation is operand 1 is greater than operand 2 or your operand 1 is less than operand 2. So whenever, if you can write here a small program like largest of two numbers, or you want to check equality between two numbers, like simple example, See, operators is very important question also. So better you write small examples, like you take two variables int. If you assign them, don't use your scanf and so on, because if they don't ask generally this, so you'll simply say, you can write here uh, printf mm, I think it should work. Let me check whether this compiler supports this line or not. Right, you are getting 0. Yes. So now if you observe here, I have you no need to use your if or something here, right? Now if here your equality is compared between A and B. So if you observe 5 and 6, 5 is equal to 6. Condition is false. So your return value for this expected output you will get 0. Suppose if I make this as 5, it should be 1. So can you observe here? A is equals to B because it's returning your value as 1. Suppose if I write here 50, it will return me a value as 0. Okay, you get 0. So you can say here, if your equality relation satisfies the rule, then your return value of this expression is true. That is nothing but it will return a value as 1. If the equality relation of this expression is false, it will return a value as 0. The such simple one-line examples, if you write, it looks more good. Someone is asking some doubt. Boolean output. Yes, obviously you'll get Boolean output. 1 and 0. Exactly. Obviously your machine returns that, right? Let's see whether if A not equals to B is working here. Should work. Yes, this is true. Okay, I'll make here also. A not equals to B, instead of comma, I'll put it as percentage. So here 50 is not equals to 5, correct? So it will give you A not equals to B value as is 1. Hope you can see that line, right? So in this way, you can give a basic examples for your relational operators. Okay, understood? Any doubt? Okay, so I'll go with the next one. So next, let's use. Then we have logical operators. So your logical operators are broadly categorized as 3 types. The first one is logical and, logical or, and logical not. So whenever you are talking about logical and relation, if your input of your expression is true, if all inputs are true, then your resultant or your written value of that expression is true. Here, if any of input is true, that is either of your input is satisfied for a true condition, then your written value is true. But not, a true value is inverted to false and a false value will be inverted to true. Okay, so now here you can write truth table like this. You can take 2 operands like this. Take operand 1, operand 2, then you will write operand 1 and operand 2. Suppose if the first operand value is true, second operand value is true, then your instant value of logical and expression becomes true. Suppose if this is true, this is false, your written expression is false. And even if this is false, this is true, your written expression is false. And even both are false, you get the resultant value as false. The introvert of or the controversy of and is your logical or. So if both the statements are true, your expression is true. If true, false is also true, because I told if any of one input is true, the entire expected resultant will become a true condition. Now false true is also true, but false returns a value as false. So if they ask about logical operators, only logical operators, you will Explain them. The first one is logical and logical not. Define the definition for logical and, that is, if all the inputs of your expression are true, then only your return value of that statement becomes true. Otherwise, it is false. Then you have to draw this truth table. And for logical or, if either of your input is true, the entire expression becomes true. Then again, you'll draw a truth table for or. And for not necessary, just you will mention a true statement is inverted to false and a false statement is inverted to true. For here, you can take one example. Like the same example, what I'll do is I can write here. So I'll write here not. I will check for equality relation. Fine. So we all know that if you see now when you do the evaluation of expression, it happens from right to left in fifth line. So first A equals to B is evaluated. We know that 5 is equals to 5. Correct? So your return value is 1. But what does not do? A not will invert a true block to false block and a false block to true. So here you will get the value as 0 now. Okay, so I'll show you both. So how not works? So you can see, actually if you see the first line of your output, it is 1. Yes, 5 is equals to 5, you got the value as 1. But when you are seeing the second statement, 5 equals to 5, it is inverted to 0. Why? Because you are using here logical not. It is not equals to, it is only logical not. Suppose if I make 50 equals to 5, in line number 5, it's correct. So I'll just print here percentile D values. Okay, then it will be more good. We'll print 5 values instead of variables. Then A comma B. Okay. Here also instead of variables, I'll write percentile D comma B. So if you see line number 5, 50 equals to 5 condition is false. So here in line number 5, first output you get it as 0. But in line number 6, we are using not. So 0 is inverted to 1. So you can see that. Observe everyone. 50 is equality relation is 0. But as it is a not condition, it is printing me the value as that is not of 50 is equals to 5 is printing as 1. Okay, everyone understood this now? Yes, clear with the logical operators? Right? So next we'll see the next one. So then we'll talk about bitwise operators. Okay, in bitwise operators, we have the first one as bitwise and, we have bitwise or, so we have bitwise and, we have bitwise or, we have the next one right shift, left shift, and the other one is exclusive or, and you have one's complement. Okay, this is also a very important question. Explain about bitwise operators they'll ask. The first one is you have bitwise and operator. This comes as bitwise or. This will be your right shift. This is your left shift. And this is exclusive or. And we also have another one, one's complement. So we have bitwise operators as 6 categories, and first point is bitwise operators are purely used on bits. Okay, that is, it is going to happen on your binary values of zeros, and it's a machine representation of operators. It works on zeros and ones. Now, the only one thing is both bitwise and or and bitwise and both are similar. That is, if one input is false, the entire expression becomes false in and. If any of your input is true, the entire expression becomes true in or. But the difference between bitwise and logical and is in logical and, for example, I have a simple statement. I have a statement A greater than B and A greater than C. If I have a line like this, for example, I have an input of A as 4 and I have B as 20. So when you are doing a logical AND, first this expression is evaluated. Is 4 greater than 20? So you get the return value as 0. Your logical AND does not go for the next statement evaluation. Your verification of your expression stops in the first statement itself, it becomes false. But whereas you're talking about bitwise AND, it will evaluate all the expressions, even the first statement is false. That is the major difference between bitwise AND logical AND. Okay, so the remaining is same. So you have the new things here. That is nothing but right shift. In bitwise, we will talk about right shift. This is right shift operator. Then we have the other one, left shift. Then we have, this is exclusive OR. And we have the other one as one's complement. Okay, this is one's complement. Now, what is right shift and left shift? Okay. Before this, I complete exclusive OR. Exclusive OR, for example, I have operand 1, I have operand 2, and we are finding operand 1, exclusive OR, operand 2. Suppose if the first input is 1, 1, if this is 1, so here you don't have true false. In bitwise, you represent only with ones and zeros. 0, 1, and I have 0, 0. What does exclusive OR do is, if both the inputs are, if all your inputs are similar, okay, if all your operand inputs are similar, then your output is 0. As OP1 and OP2 both are inputs 1, 1, 1. Okay, then your resultant will become automatically 0. If you have any alternate operands, that is, if you have the combination of ones and 0, then your result will become 1. So all zeros also you get the output as 0. Once again, in exclusive OR, if all your type of inputs are similar, either it is ones or combination of it is only zeros, then your resultant output is 0. If your combination of your operand inputs are combination of ones and zeros, then your output will be 1. Okay, that is, if you have 1 and 0, your result is 1. If you have 1 and 1, the result will be 0. So this is exclusive OR. So next we have left shift. We have left shift operator. The other one you have it as right shift. So the name itself, left shift and right shift, you are shifting. You are not shifting the places, we are shifting the position of bits towards left side. That is how many times is depending on your number of input. Right shift is shifting the position of bits towards right. We are not increasing here, we are only moving the position of bits from one location to another. Either that location shift can be towards left side or that shift can be towards right side. For example, I have an input. Let's take it as I have A is equals to 5. I see 5 left shift by 1 and 5 right shift by 1. So this is my expected, these are my expected operations which I have to perform. So what should I do? First, convert this 5 decimal form into binary mode. Okay, first we need to convert. I have given a is equals to 5 and I'm asking 5 right shift by 1 time, 5 right shift by 1 time. So first you will convert this decimal number to binary notation. So we will convert, you will take this. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 1, 2, 4, 8, 16. So these bits are zeros. 4 plus 1 is 5. This is your representation of a is equals to 5. Now what is he asking you to do? 5, that is a left shift by 1. You have to shift your bit. So we'll do this. So 1, 2, 4, 8, 16. So what you will do now, you will shift these bits towards left. So this 0 is moved. So this 0 comes here. This 1 comes here. This 0 comes here. This 1 comes here. The less number is automatically appended with 0. So your answer, when you shift 5 towards left by 1 time, what is your answer? You will add only the position of bits where you have 1. So 8 plus 2 will give me a resultant value as 10. Understood? So now for the same expression, if I do right shift, 5. So this one is lost. In right shift, you are not going to preserve this one in the front. This one will be automatically lost. So you'll get 0. This one and the remaining bits are 0. So your answer for this will be 2. So if I shift 5 by left to 1 time, your output is 10. And if I shift 5 towards right by 1 time, your output will be 2. This is about your left shift and right shift operator. So you'll write a simple example here. So I'll tell you in easy way. So someone is asking big numbers. So you can take simple. Suppose if you are doing left shift, remember one thing. You are doing the original number multiplied by 2 to the power of number of shifts. Okay. And if it is right shift, original number divided by 2 power number of shifts. You can do it directly. For example, I gave a value of a is equals to 128. Okay. In exam, don't apply the formula, but you just check your answer when you do shift 128. First, you will represent in binary form. So if you substitute here, you get 128 multiplied by 1 time shift. Suppose if I say left by 1 time, you will do 2 power 1. So you get the answer as 256. Similarly, if I do 128 divided by 2 power 1, I get it as 64. Okay, now you can justify this answer. I'll just show you with small example, then you'll understand whether this formula is correct or not. Previous example we did not 5. So when A was 5, okay, when A was 5, what is the answer you got? When A value is 5, when I did left shift, I got 10. So 5 into 2 power 1. So you get the answer as how much? 10. Now when you divide 5 by 2, you get the quotient as how much? 2. The same thing you got, right? So whenever numbers is given, better you do it like that. Okay. So someone is asking for a big number. So let's take a is equals to some 64. Okay, first I'll represent 64. Let's take you want to shift it by 2 times. Okay. So what is the formula if I do left shift? 64 into 2 to the power of number of shifts. So you get the answer as 64 into 4. You have to get the answer as 256. We'll see. This is 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, and you have 2 power 6. So this is 1, 2, 4, 8, 16, 32, 64. So I'll take for an odd number so that you'll understand how that right shift is also working. So 65, how will you represent? 64 plus 1 is 65. The remaining bits are zeros. Now I said you have to shift 65 towards right left by 2 times. So first you take the format. Okay, this is 1, 2, use another pen. 4, 8, 16, 32, 64, 128, 256. Similarly, 1, 2, 4, 8, 16, 32, 64, 128, 256. It will be another number now because I did 65. So first, this value, the place where you have 64, it is shifted to 128. The remaining bits automatically are zeros. Now, whatever the value you have in 1, it is shifted to 2. This is the first shift. Now the second shift I will apply. The value which is at 128 shifted to 256, the remaining bits becomes zeros. Now whatever the value you have in the position 2, it will be shifted to 4. The remaining 2 bits are 0. Now what is your answer? 256 plus 4, which will give you 260. You can apply the formula. 65 into 2 square. 65 into 4, which is nothing but 260. Understood, everyone? Clear? Someone asked me 59F roll number. Done? Clear? Okay, so you will show that exam. Right? For right shift also you will use the same method. Okay, fine. Now the next one more we have, that is nothing but ones complements. Ones complement is nothing but inverting ones to zeros and zeros to ones. Okay, what does this mean? For example, I gave a is equals to 2. 2 first you will represent in binary form. How? 1, 2, 4, 8. So your answer is 0, 1, 0, 0, 1, 0. Now wherever you have zeros, you will invert them to ones, and wherever you have 1, it should be inverted to 0. So this is your expected output generally. But this is wrong. What does your compiler do is, if it, as a user, what am I doing? If you want to represent one's complement, what I will do, in order to represent one complement, I will take only how many bits are needed, right? Fine. So if I have a number as a is equals to 2, in order to represent 2, I'm using only 4 bits. But your compiler doesn't do that. If your processor is 4 bytes long, it is going to use 4 bytes. If your processor is 2 bytes, it will automatically use how many bits now? 16 bits. 5, 6, 7, 8, so on up to 16. That is 2 power 0 to 2 power 15. So in order to represent 2 power 1, 2 square, 2 cube, and so on, you have something like this. Now in order to represent 2, you will have these bits as zeros initially, and this will become 1, and this is 0. Now what does one's complement do? The symbol does inversion. That is, zeros should be inverted to 1 and 1 should be inverted to 0. So this is 0. This will be inverted to 1s. All the bits in between. Only the bit at this location is inverted to 0. So if you translate this expression in one's complement, it is nothing but you get it as -3. Remember, whenever your input for your one's complement is a positive number, it is inverted to negative number. That is why, because if you see, this is your, you call this as MSB bit. In MSB bit, whenever you represent a positive number, it will be 0. If it is a negative number, it is 1. If you observe here, your MSB bit is 1. Definitely, your 2 is inverted to -3. So you don't go into much details, but when you give example, one's complement, you write the definition. Invert ones to zeros and zeros are inverted to ones. For example, I have an input as a is equals to 5. What should be our output is minus of original number plus 1. This is the formula for one's complement that is going to happen. This minus is talking about your sign inversion. If it is positive, it is inverted to negative. If it is inverted to negative, if it is negative, it is inverted to positive. So you get what is the expected output? You get it as a is equals to minus of 5 plus 1. So you get a is equals to -6. Suppose if I give a is equals to -12. So what I get, a is equals to minus of -12 plus 1. So you get the value as +11. Okay, I'll just show you that. So here, let's give an example. I'll show you. Let's give minus 15. Okay. So here I'll just simply write uh, complement of A is equals to percentile D, comma, 1's complement of A. Okay. This is for positive number I did, first one. Then slash complement of B, sorry, complement of B is equals to percentile D, quotations close, comma, complement of B. Okay, so if you observe here, minus, what is the formula I told? It is minus of original number plus 1. So A it is minus of 50 plus 1. So you should get your resultant as 51. And here it is minus of minus 15 plus 1. You have to get it as 14. Here it is minus 51. Okay, let's see. So you can observe. Everyone are able to see that? Can you see the output? So that is the thing that happens. As a user, to represent 50, we use 5 or 6 bits, but your compiler doesn't do that. It allocates you complete 4 bytes of memory. So as your MSB bit is 1, if it is 0, it is inverted to 1 automatically. So 1 represents a negative number. That's the reason you are getting a negative sign if your input is positive. And similarly, for 14, it is, I get 15 as negative number. So you got the output as positive number. Ma'am, the explanation part with bits division once again. Which one? One's complement you're asking? Someone else? Okay, fine, understood. So as I said, if A's value is 4, or let's take it as something 6. So how it will take, for example, your processor is 2 bytes, it will take 2 bytes now. This starts from 2 power 0, 2 power 1, 2 squared, so on up to this is 2 power 50. So 6 means what? 4 plus 2. So 1, 1, 0, the remaining bits are 0. Now when you apply complement on 6, all these are inverted to 1s. These bits are inverted to zeros. This is your answer. So if you calculate this in very detail, this you will learn it later. That's the reason I'm not explaining you. So as your MSB bit is 1, indirectly we understand this is a negative number. If MSB bit, that is most significant bit is 0, you will understand it is positive. Otherwise, if MSB bit is 1, we understand it as a negative. That's the reason you are applying a formula technique that is